In July 2022, the James Webb Space Telescope opened its eyes and took its first deep image of the universe. Scientists expected galaxies. They expected stars. They expected beauty. They didn't expect this. Scattered across the image, tiny, bright, ruby red dots. Not stars, not galaxies, not anything in the textbooks. At first, there were 6, then 40, then 300. They were everywhere, in every image Webb took, no matter where it pointed, and no one could explain what they were. This is the story of the little red dots, the objects that may be the most important discovery Webb has ever made, and possibly the most terrifying. Here's what makes the little red dots so unsettling. It's not just that they exist, it's how many there are. When astronomers first spotted them in Webb's early data, they found 6. Strange, but not alarming. Then a dedicated survey called Rubies spent 60 hours scanning 4,500 galaxies and found 40 more. By early 2025, the count had reached 341, and they keep finding more. These objects are compact, incredibly bright, and distinctly red. They show up when the universe was only about 600 million years old, less than 5% of its current age. And then, roughly 1 billion years later, they vanish completely. Something appeared everywhere in the young universe, burned intensely for a cosmic instant, and then disappeared. The question was obvious. What were they?
For 3 years, astronomers tried everything. They built models, they ran simulations, they argued at conferences, and the little red dots refused to fit any category. Then, a team found one that changed everything. They nicknamed it the Cliff. Its spectrum showed something no one had seen before. When you break light into its component wavelengths, you get a graph, a signature that tells you what an object is made of and how it behaves. For most galaxies and black holes, this graph is smooth, predictable. The Cliff spectrum was not. Almost zero ultraviolet light, then a sudden, sharp spike into longer, redder wavelengths. Not a gradual slope, a wall. A cliff in the light itself, as if something was absorbing all the high-energy light and only letting the red through. No normal galaxy does this. No known black hole does this. Not even the most extreme active galactic nuclei produce a spectrum like this. But there is one scenario that fits perfectly. Imagine a black hole, not a giant one, but a young one. 100,000 to 10 million times the mass of the sun. Still small by cosmic standards. Still growing. Now wrap it in a dense cocoon of hot, ionized gas. Not a thin shell. A thick, heavy blanket of superheated plasma. The black hole is feeding. It's pulling in material from the cocoon, generating enormous heat. Temperatures reach millions of degrees. Under normal circumstances, that heat would radiate outward as X-rays and radio waves, the classic signature of an active black hole.
But the cocoon is too dense, too thick. The X-rays slam into the ionized gas and get absorbed. The radio waves get trapped. The cocoon acts like a prison for high-energy light. The only radiation that manages to escape is lower energy light, visible and infrared. And even that doesn't get out cleanly. As the photons fight their way through the cocoon, they collide with electrons. Each collision scatters the light, shifts it to longer wavelengths, pushes it redder. By the time the light reaches the outside, it has been filtered, scattered, and transformed. The ultraviolet is gone. The X-rays are gone. All that remains is a faint red glow. From the outside, you wouldn't see a black hole. You wouldn't see an accretion disk. You wouldn't see jets. You would see a small, bright, red dot. And if you pointed an X-ray telescope at it, you would see nothing. Exactly what happened.
In January 2026, a team at the University of Copenhagen published their answer in the journal Nature. After analyzing the highest quality spectra Webb had ever collected from little red dots, they reached a conclusion that stunned the astronomical community. The little red dots are a new type of object, one that has never been observed before. They call them black hole stars. Now, this name is deliberately strange because the object itself is strange. It's not a star. It's not a black hole. It's something in between. Something that doesn't exist in any textbook written before 2025. A black hole star is a massive ball of gas, larger than our entire solar system, powered by a young supermassive black hole hidden at its center. The gas is so dense and so hot that the entire structure radiates like a star. But it's not powered by nuclear fusion, the way real stars are. It's powered by gravity, by the black hole consuming material and converting it into raw energy.
Let's bring this home. Every large galaxy in the observable universe has a supermassive black hole at its center. Not some, not most, every one. Our Milky Way has Sagittarius A star, 4 million times the mass of the Sun. The Andromeda Galaxy has 100 million solar masses. The galaxy M87 has one that weighs 6.5 billion solar masses. That's the one we photographed in 2019, the first image of a black hole ever taken. These objects are ancient. They are enormous. And for decades, they've posed one of the biggest unsolved problems in astrophysics. The problem is simple. The universe is 13.8 billion years old. That sounds like a lot of time, but it's not. If you start with a small black hole, say a few times the mass of the Sun, left behind when a massive star dies, and let it feed at the maximum possible rate, it still can't grow to 1 billion solar masses in the time available. The math doesn't work. You run out of time. You run out of material. The radiation from the feeding itself pushes gas away and slows the growth. And yet, Webb has found supermassive black holes that were already enormous when the universe was less than 1 billion years old. They shouldn't exist.
The James Webb Space Telescope was built to answer questions about the universe. Instead, it found something no one was looking for, and it may have accidentally solved one of the oldest mysteries in cosmology. Some astronomers now say the little red dots could be the most important discovery Webb has made. Possibly the most important discovery in cosmology since dark energy was found in 1998. And we're still early. Webb is still scanning. The count is still rising. And this August, NASA launches the Roman Space Telescope with a field of view 200 times wider. If little red dots are everywhere Webb looks, imagine what Roman will find. The little red dots aren't gone. They just finished hatching. If you want to see what else is hiding in the universe, subscribe, because we are only just beginning to see what's really out there.